The chi-square test for association examines whether two categorical variables are related. It is also called the chi-square test of independence. We use this test when we have a contingency table of counts and want to know whether one categorical variable is associated with another. Examples include smoking status and lung disease, genotype and phenotype, or gender and product preference. This image summarized the overall setting for a chi-square test for association. The null hypothesis says the two categorical variables are independent. The alternative says the variables are associated. Independence means that the probability of being in a particular row and column equals the probability of the row times the probability of the column. The assumptions are that the data are counts, both variables are categorical, the sample is random, and all expected counts are at least 5. For each cell in the table, the expected count is the row total times the column total divided by the grand total. The chi-square statistic adds up the squared differences between observed and expected counts, divided by the expected counts, across all cells. The degrees of freedom are the number of row categories minus 1 times the number of column categories minus 1. The p-value comes from the upper tail of the chi-square distribution. If that p-value is small, we reject h sub 0 and conclude there is an association between the two variables. A significant result tells us that an association exists, but it does not completely explain which cells are driving that association. Common follow-up tools include standardized residuals, adjusted residuals, and pairwise proportion tests. In example 1, a researcher studies smoking status and chronic lung disease in 400 participants. The two variables are smoking status and disease status. This table shows the observed counts for non-smokers, past smokers, and current smokers across the two disease categories. For the first cell, the expected count is 200 times 75 divided by 400, which equals 37.5. The remaining expected counts are found the same way. The chi-square statistic is about 20.923. The degrees of freedom are 2, and the p-value is less than 0.0001. Because the p-value is so small, we reject h sub 0 and conclude that smoking status and lung disease are associated. Disease status varies across smoking groups, more than we would expect by chance alone. This image shows the jump output for the chi-square test for association. The main takeaways are that this test is used for two categorical variables. The null hypothesis is independence. Expected counts come from the row totals and column totals, and a significant result indicates an association.